This is the first lecture out of chapter 19, so balancing oxidation and reduction reactions. So oxidation reduction reactions is something that was covered in General Chemistry 1, and oxidation numbers were covered in General Chemistry 1. So if you don't remember that material, then I recommend that you go back and review it first. And I do have some lectures posted over the General Chemistry 1 oxidation reduction material, so I recommend that you go ahead and watch those videos first. Okay, so if we're going to take an oxidation reduction reaction and balance it, it's a lot more complex than balancing just a normal chemical reaction. So what we're going to do first is balance it in acidic solution. And as you can see, there's a lot of steps to go through. And then once it's balanced in acidic solution, if you wanted to, or if the question asks for you to, you could balance it in a basic solution as well. So these are the steps. So we're going to take an example. So we'll take this example and go through each of these steps. So let's balance this oxidation reduction reaction in both acidic, and then once it's balanced in acidic solution, then we can balance in a basic solution. Okay, so the first step is to assign oxidation numbers to everything. So if you remember how to do this from Gen Chem 1, so oxygen is -2, so that's 8 negatives. And whatever manganese is, it's got a sum to -1. So if there's 8 negatives, then manganese must be +7. So +7, 8 negative gives you a net -1 charge. And for SO3 2-, again, oxygen is always -2 unless it's O2 or H2O2, and then oxygen is -1. But in all other compounds, oxygen is -2. So 3 oxygens, so that gives you 6 negatives. It has to sum to -2, so that means sulfur must be +4, right? +4, -6 sums to -2. And then on the right, oxygen's -2, that's 4 negatives. The net is 0. Since there's no charge shown, then it must be 0. So if oxygen's -2 and 2 oxygens is -4, then manganese must be +4. And for SO4 2-, so again, oxygen's -2, that's 8 negatives. It has to sum to -2, so sulfur must be +6, right? +6 and 8 negative sums to -2. Okay, so we've assigned the oxidation numbers to everything. So now what we need to do is write the two half reactions. So what you want to do is split this up into things that go up in oxidation number and the things that go down in oxidation number. So manganese, MnO4-, manganese went from +7 to +4. So how do you go from +7 to +4? Is you must gain electrons. So it must gain 3 electrons. So that would be one of the half reactions. And then the other thing that changed is SO3 2-, sulfur went from +4 to SO4 2-, sulfur went to +6. So how do you go from being +4 charge to +6 charge? Is you must lose 2 electrons. So you can think of electrons as a product of the reaction and write it on the right side of the arrow. Whereas the other one, you can think of electrons as a reactant to react with MnO4 to make manganese go from +7 to +4. So that's your two half reactions. And so now we want to balance them independently of each other. So we want to balance, so now we're at 3A. So balance all atoms except oxygen and hydrogen first, and this is already done. There's one manganese on the left, one on the right. There's one sulfur on the left and one sulfur on the right. So that part's already done. So then we can move on to 3B. So we did that. I balanced the oxidation numbers using electrons. So +7 and 3 negative gives you +4. And +6 and +2 negative electrons gives you +4. So so we balance the oxidation numbers using the electrons. Okay, so now we want to balance oxygen atoms using water molecules. So we have 4 oxygens on the left for manganese, MnO4, and we have 2 oxygens on the right. So we need the same number of oxygens. So we need to add 2 water molecules to the right. So now we have 4 oxygens on both sides of the arrow. And for the other one, SO3, 2-, we have 3 oxygens on the left and 1 on the right. So we need another oxygen on the left. So we need to add a water molecule to the left. Okay, so now sulfur is balanced, oxygen's balanced on the left, manganese is balanced, and oxygen's balanced. So now then we can balance hydrogens. So we balance hydrogens using H pluses. Okay, so we have, for the manganese reaction, we have 4 hydrogens on the left, on the right. So we need 4 hydrogens on the left of the arrow, so we use H pluses to do that. So we need 4 H pluses. So now hydrogens is balanced as well. And for the reaction on the right, the other half reaction, we have 2 hydrogens, 2 water molecules on the left, so 2 hydrogens, so we need 2 hydrogens on the right of the arrow. So we need to add 2 water molecules, no, one water molecule. No, we have 1 water molecule on the left, so that's 2 hydrogens, so we need 2 H pluses on the right. So now it's balanced in terms of hydrogens. Okay, so then we go on to E. So we need to balance the number of electrons between the 2 half reactions. So the manganese half reaction has 3 electrons, but the sulfur half reaction has 2 electrons. So we need the common number of electrons between the 2. So the common number of electrons would be 6. So if we need 6 electrons in each half reaction, so the manganese reaction, we need to multiply everything by 2. And the sulfur reaction, we need to multiply everything by 3. So we need to multiply everything in the reaction by those numbers. So then we have 8H plus 2 MnO4 minus plus 6 electrons to make 2 MnO2 plus 4 H2O. And for the sulfur reaction, we need to multiply everything by 3. So 3 water molecules plus 3 SO3 2 minus makes 3 SO4 2 minus plus 6 electrons plus 6 H plus. Okay. So now then we can, now that the electrons are balanced between the 2 half reactions, we go on to step 4. So now we need to recombine the 2 half reactions to make 1 reaction. And then when we do that, after we do that, when they're going to cancel like species on opposite sides of the arrow. So everything on the left of the arrow stays to the left, everything on the right of the arrow stays to the right. So if we combine these 2 half reactions, we have 8H plus 2 MnO4 plus, so the 6 electrons are going to cancel because we have 6 electrons on the left and 6 on the right, so they're going to cancel each other. So plus 3 H2Os. So now we take the left side of the other half reaction and write it. And now we write everything that's on the right of both half reactions. Okay, so now what we want to do is cancel like terms. So we have 3 water molecules on the left and we have 4 on the right. So we can cancel 3 of those and only leave 1 left on the right. And then we would have had 6 electrons here and 6 electrons here. And then we would cancel those as well. And so now we can rewrite this equation after we've done the cancellations. So now there's only one water molecule left on the right. Okay, so that should be, nope, sorry, we gotta cancel H pluses as well. So 6 H pluses on the right cancels out 6 of these, so there's gonna be 2 left. And these on the right are gone. Okay, so 2H plus plus 2NO4 minus and 3SO3 2 minus to make 2, sorry, it should be MnO2, which I made a mistake here. Right, that should have been 2, because it was 2 here to begin with. So that's MnO2, and that's MnO2. Okay, so we make 2 MnO2 plus 1 water molecule and 3 SO4 2 minus. So that would be the equation. Balanced in acid solution. So now once we have that, then we can, if we wanted to balance in base equation, then there's 2 more steps that we have to go through. So then we can move on to step 5. So note the number of H pluses and add that many OH minuses to both sides of the arrow. So we have 2 OHs on the left, so we can add 2 OHs to the left and to the right. Okay, so we added 2 OH minuses both to the left and to the right. And now what we want to do is we want to let OH minus react with H plus on one side of the arrow. So one side of the arrow is not going to have H plus because we canceled all of them out. Only one side of the arrow will have H pluses, and then we can let them react with the OH minuses. So that would make 2 water molecules. So now we can rewrite the equation again. So now we have 2 H2Os. And now what we want to do is let like terms on both sides of the arrow cancel each other out. So we have 2 water molecules on the left and 1 on the right, so the 1 on the right can be canceled, and that would leave 1 on the left. And then rewrite the equation again. So now we only have 1 H2O on the left. Okay, and then that would be the equation. So that's the final equation. That would be balanced in a basic solution. Yeah, so if you went through the equation, you should have the same number of each element on both sides of the equation now. And it's balanced in base because hydroxide is a base. So this will be balanced in base solution. Whereas in this, the first previous one, H plus is an acid, so that would be balanced in an acid solution. Okay, so it's a lot of steps, but that's what you have to go through to balance a redox reaction, an oxidation and reduction reaction. Sometimes they're simple, but sometimes you don't have to mess with waters and H pluses and OH minuses. But if it asks you to balance an acid or balance an base, then that's the steps that you have to go through. Okay.